Hi, welcome to Linux channel. So whenever I shoot video episodes on Linux kernel programming, say for instance proc file system and various episodes of drivers and stuff like that you must have seen, I'll be populating the file operations or the FOPs. So this video I thought of exclusively discussing about a few examples of FOPs and FOPs. Actually, if you see, it is not just meant for kernel, it is also you can find in user space development as well. The whole idea of FOPs is to handle the provided services of the data structure. See, sometimes this data structure could be any service like any driver or something like that. So you can populate the FOPs, which are nothing but function pointers. It is called as file operations, but it is actually nothing but various function pointers. If you populate it will do any specific task when some event happens, say for instance any packet arrives or something happens, then it will trigger that FOPs registered function. If you don't populate, then it will treat it as the functionality is missing in that specific implementation. So this is the major role of FOPs. Hence you need to understand, if you are a beginner, you don't need to populate all the FOPs. Sometimes you see any examples in the book or online code examples, you can find somebody populating few FOPs, somebody else may populate different FOPs. Actually, some may populate all read write etc, some may not populate everything. So you should understand, say for instance even proc file system you take as an example. If you are supporting read write, then you may have FOPs for both. If you don't support write operation, it is just a read operation, proc file, then you don't need to populate that write operation. So this video we discuss about various examples of file operations or FOPs, especially in the kernel programming, kernel proc file sample code which I did in multi episode series. So we can pick any of this example. We can take anything as an example. So for instance, we take this writing a proc file or reading a proc file. So we take these two examples. So let me open this article in a new page. So you can see this is the sample code, and if you notice here I am populating this file operations or FOPs. So you can call, I generally call in short as FOPs. I don't know, it is an industry norm because these are the various file operations, and you can see there is a dedicated data structure and in which we populate. Okay, so if you see here, this is the main proc data structure, proc dir entry. So please note, some of these things will change drastically if you go through any old examples of kernel code. I mean, if you read any old books, if you read even LDD, it may look somewhat different, or any online sources it may look somewhat different versus here it may look different, and if you go through the current kernel source it may look different. As I always say, kernel is always getting developed, so obviously we will get this sort of change. So when I was doing this, it is so and so version of kernel, and so it is compatible for that version of kernel of that era. Okay, so hence you can see the main data structure is this. So if you have multiple files, you can do instantiate multiple instances. So in this case it is just only one instance. In case if you have any kernel code, if you are having multiple proc files, so then you need multiple instances. So you can see that this is the proc file, and we are doing this proc create, and we can mention whether it is read write, whatever permissions, or if it is any directory, then what it is going to have. So in this case it is just a regular file with this permission, so it is only read permissions, hence it is 444. So any user and a group or others, everybody can only do a read operation but not a write operation. Hence in this episode I am discussing this example source code, versus in this episode I'm kind of improvising the same source code and I'm adding this write support as well. Hence I'm changing this permission to 666. So it is also getting this read as well as write permission for all users. Okay. So in this case you can see this is the FOPs versus in this case this is the FOPs or the file operations. So you can see here we are mentioning the read is supported and the corresponding data structure which is associated for this read operation means whenever you do any read of this proc file from the user space, it will trigger this API, and whatever you write in that API will be sort of executed, and the proc thing is supported. Hence you can see there. So in this case I am doing something and we are sending something from kernel to user. So in general you can use the proc as an interface to communicate between your kernel code and user code. So this is again I mentioned in my proc episode. In case if you are curious, I will add these links, you can go through this old video episodes. So one of my favorite interface is proc interface whenever I do kernel development. You can also do any character driver in case you want to get a stream like data. Of course you can't do proc if you want something like a stream like data, means you want to get a set of network packets you are tapping from kernel space to user space from your own custom source. Okay, so in that case you can also use something like a character driver, and in case if you are doing some driver, if you have any standard IOCTL, then it may be through IOCTL and stuff like that. But proc is very simple. As I say, you can also do multi language support, because you can write user space components in Python, Perl, etc. Or even PHP and Bash scripts, because it's just a file operation. You can do a read of that file in a simplistic way without any native support, unlike this IOCTL APIs. In case of IOCTL, you need to write some C or C++ code. You cannot just like that write some Python code and then interact with the kernel, since IOCTL is like that. Okay. So you can see in this case we are populating. So in this only the read is supported. So we are supporting this read API. You can keep any name of this function which corresponds to this proc file, and in this case we are supporting both read and write. So that's the whole episode is about creating a proc file which has both read and write support, and in this case we are mainly emphasizing the write operation. I mentioned this title of this video episode as write proc file, but of course it has that read support as well. So here if you see the file operation, it should have both this read as well as write. You can also do, in case you don't want read at all, you just want a write only file, then you can create that as well. So you can just basically you can take the same source code. You can take the same source code. Let me just copy this part. Let me just copy this part. So we open in an editor, and everything should remain the same. Here we are mentioning it's only the write part, so it is we can give the appropriate permission. So it is 4 is for read, so it should be 555 or something like that. Okay, so that it doesn't have the read access, it was only the write access. So something like that you can give that permissions obviously. And here you don't need to support this read API, you can just remove this. Now the file operations has only write access, and correspondingly you can also provide this access as well. So 555, so it should be 101 or something like that. So it should have only that read only access. Okay, so in this write only access, so 4 is since it is a binary this thing, decimal binary, so 100 is read. Okay, so versus plus 10, so this is read write, so it is going to be only 010. So something like that. In that case it should be 222. That makes it only write only supported file. So something like that. You can anyway compute that and populate here. So when it comes to FOPs, you can basically populate like this, and you can remove this write API. So in this case we are supporting only the read operation. So you may ask what is the purpose of this, and where it is used in real world. So this I have done extensively in my traffic squeezer also in the past. The reason for this is quite simple. You need to pass some configuration from user to kernel space, and you don't need to read that configuration what you sent. Hence you can use a dedicated file, a proc file, and support only the write operation, and then you can populate the file input using the echo command, or you can do it with the C code as well. And then the moment you write the file in the user space, it will be sent to the kernel space, and obviously it will be taken care provided you do some sort of parsing of that provided input in the kernel side. Obviously you can pass any data, so you can pass some JSON, or not JSON, you can pass some primitive TLVs. So you can say you can do something like this, echo. So even we can try it in command line itself. So let's say, so these are various proc files. Often the proc files has read permissions. So ls minus lh, and you can see most of the files have read permission, very few will have write permission. So most of them should have read permission. Since these are the above ones are directories, it has read and write permission, and it has this marker as a directory. Okay, so whereas the other files has only read permission. So cat proc CPU info, you can see there it has only the read permission, so we get it in the user space. So suppose we need to send something to the kernel space, so we can mention some sort of TLV. Okay, so ABC, some variable equal to 100, and then we can pass like this, so XYZ file inside the proc directory. Okay, so something like that you can support like this, and it will be sent, and you can write the corresponding parser. Your string what you get is something like this, ABC equal to 100, and you can parse it. You split that type and value. Okay, so in the case of this example, the type is ABC, so there is a variable called ABC. Hopefully in the kernel it is there, and you need to populate its parameter. So its value is 100, so you can do this equal to, you can use it as a delimiter, split into two strings. One string should have this type, if it is ABC, populate that respective populate that respective variable. You can also have something like this, XYZ equal to 100, or XYZ equal to 200, something like this. So it means you have one variable ABC which is 100, and you have another variable XYZ which is 200, something like this in the kernel code, and that you can get it. Yeah, say for instance, you can see here itself we have the ABC XYZ. Let's assume we are initializing to 0, so we can get that value from user space to kernel space, and then we can parse it, and then we can populate this variable. So that variable could be any parameter with the driver, it can be any configuration setting in your kernel code, and hope you got an idea. So if you want, you can also pass a string, you can also pass an integer, and things like that. This is very commonly I do all the time in my kernel code as well. Okay, even recently I'm supposed to do some proc file where I get the LAN port settings, which port is assigned to the LAN port. I need to send from user space to the kernel space, so that for instance ETH0, ETH1, whatever that port corresponds to the LAN port, I need to get it in the kernel space, and then followed after that I need to do some packet processing and stuff like that. So I may do this similar logic in my own code as well. I mean to say the production code, but I'm giving all the kind of fundamentals. So hence the file operations in this example, it is very simple. It has few things, and with this, based on that a data structure, in this case this proc service, we are populating that needed file operations. So now we can move on to a bit more complicated one. Say for instance, we can go to the kernel source, and if you notice the recent last video I discussed about the stun tab IOCTL handlers, we can go to that source, and we can see the file operations of various data structures of that code as well. So we can go to this driver net. See, this is one thing, since I work in mostly Linux kernel and network stack, I take examples in this space, but in case if you are working in any video drivers, in case you are working on something else, okay, you can use these examples and you can refer your corresponding code or examples. Okay, so you can see here, we are here and we can go to this stun tab and we can search for file operations, and you can see this. Okay, so in this case it is tab FOPs versus here it is stun.c. By the way, this is drivers net tab.c, this is drivers net stun.c, and in this case we search for file operations. So you can see there it is stun FOPs, and in this case it is tab FOPs, and we see like where is this getting registered, and you can see some it is getting populated, but in general the file operations may have various other things which is not all the time used. Hence, depending on the need, you should use those FOPs and you need to populate those linked functions. So you can see tap open, tap release. If it is open, then tap open. If it is released, then tap release and stuff like that. But you can see here what has been done, dot write is not existing over here. So in that case, that particular file operations is not populated over here. At the same time, what is being populated here is not populated in this example. So this is what. So you can see here it is ton FOPs. In this case, there are few which is supported, some are supported conditionally. You can see there if and if. So if it is something make menu config, you enable, then it is supported. You don't enable, then it is not supported. So these are supported conditionally. Some are supported unconditionally. You can see here. So we can see ton FOPs. Where is this getting registered in this example? So search for this ton FOPs and you can see it is somewhat linked over here in this MISC miscellaneous device, ton misc device, something like that. And you can see here this ton misc device is another struct. See, this struct is this instance. In this there is FOPs, and that FOPs is nothing but file operations, and that file operation is getting populated here, and these FOPs have various APIs which are populated over here. Populated, I mean if you're a beginner, try to understand it's been coded there. Okay, so that's what I mean populated. So you can see there ton chr read iteration, something like that. So you should able to see that API written on top. So the API written on top is what I meant populated. Okay, you can see that ton chr close. So go down here, you should see that ton chr close or something. Yeah, you can see there that has been populated for this dot release FOPs. So you can see this data structure ton misc device, we can search this data structure. Yeah, that data structure is somewhat linked in the initial misc register, which is actually is in this ton init. So it is almost like this module init, and you can see there. So this is how the flow. Let's not too much get into ton type example. So our objective is to understand the FOPs and the significance of the FOPs. Especially you need to understand when you are getting into driver development. Similarly, you can see in the case of tab FOPs, you can see, let's search where this is getting initialized. Yeah, tab FOPs, it is getting used in these sections. Yeah, cdev init something. So tab create cdev, and in this it is getting added up in this API. So that's what. So another interesting thing we can do is, let's summarize and see various locations. The FOPs or this file operations, data structure is being referenced in the kernel source code. So just click over here and you can see here it shows the header file of this data structure, file operations data structure, and you can see there read, write, etc, etc, etc. It is supported. If it is read, this is supposed to be the file function pointer argument structure. I mean the argument sequence. So that corresponds is what our code supposed to be. So you see here read, then it is a struct file, then char, buffer, and then size, and then something. So that should match this. Okay, so hence if you read such things, a kernel source code example of any book which is printed many years ago, this may change. Hence that same code now you compile, it will not work. I mean it will not compile, and even if it compiles, some error you may get runtime. So in case any pointer or something gets changed. Okay, so hence you should bear in mind if you need to do any porting. Again, my last reel I discussed or shorts I discussed about this kernel porting. So if you are doing any back porting or forward porting, you should have a look about this structure, or you can also just like that read this kernel source and take any working example and just try to understand what they are trying to do, and then do that subsequent changes in your source code as well. Okay, yeah, so we search, you can see that this is what, in this case, this read write is what we populated in this proc example. And apart from that, there are various handlers are there, and you can see that the function pointer argument structure you can see here. Okay, so that's what it is. But if you go down, you can see there are various places it is referenced. So you can see here, so that data structure is being utilized in all these areas. So you can keep seeing here, let it be any driver. Okay, so drivers, scroll down, you have various file system subsystem code base. You can see here it is referenced there. Then the basic kernel core stuff you can see there. So this is what it is. So let's take this NFS some file.c, something like this. We take this example, and you can see here these are various FOPs, and corresponds to that they populated these FOPs, and you can see here, and each entry is nothing but a particular function, or you are adding the functionality of that thing, I mean functionality to your driver. So essentially what it means is, in this case we have this proc example. Why I am taking this is the most simplest thing to understand, rather than you see something this complex. Okay, so we take something so simple. See, we are adding this functionality is to create a proc file, and then we are adding the functionality. It should able to read, support the read operation. It should able to support the read and write operation. In one episode it is both read and write operation. So we are supporting the functionality. So the functionalities which it is supposed to support, we are defining in this file operations. And so which are the functionalities it is supposed to support, you populate those functions or those APIs, and then you register in the FOPs. So that's the whole idea. So you can see here, these are the functionalities it is supporting, hence they wrote the functions or those APIs. See, NFS lock, NFS F lock, you can see here, this is the API NFS F lock, NFS lock is here, and those are the functions which are going to support those functionalities which are registered in the file operations or the FOPs of that data structure. In case if one example is not like you can see in the case of file system, it is populating some functionalities. In case if you are looking for something else and it is missing in that example, go through this list and figure out which it suits your specific need or the area you are working, the your stack or the kernel stuff, and that you can take it as an example and try to understand. And once you get an understanding, then you can write your own custom FOPs functionalities. Again, having said, I'm also not a big expert on this uh, various drivers. I have a limited scope. The things which I work, I'm good at it, but there are also a lot of other things I generally don't much bother to understand either. So the if there is any eventual necessity in the future, then I may go through and try to decode what it is happening, but other than that I don't much bother various things, okay, which is beyond my scope of understanding or interest as well. So hence I'm saying, just go through this approach and try to quickly get an idea that the FOPs, what you see in book examples versus what you are trying to achieve. If there is anything you are not finding it in those examples, try to see in the kernel source of similar examples, and see what can be done in your specific implementation. But hope you got this entire idea about this file operations and the reason why it exists, and how it has been you know put together in a kernel code base. So same thing, as I said in the beginning, same thing happens in the user space as well, but this is much more, I feel, although kernel is difficult to understand, this is much more easy to understand when it comes to this FOPs capabilities of any data structure. So hope this video is useful and insightful. If you have anything to discuss, be in touch via mail, or you can post your queries in YouTube comments as well, if it is something very small. Since we can't post any screenshots, I always encourage viewers to be in touch in a mail or even in WhatsApp as well. So thanks a lot for joining me. Stay tuned. Have a nice day. Bye bye.